Hey guys, in this video I'll talk about how Python handles some of our most basic operations that we perform every day under the hood. So I'll start with a simple example, such as performing iteration over a simple loop, and then we go down all the way to the interpreter level and understand exactly how Python executes your piece of code. So by the end of this lesson, not only you'll understand how Python performs on your code, but also you will have a better understanding of how your everyday tools such as for loops, while loops, iterables, and iterators work. So stay tuned if you're interested. So without further ado, let's dive in. So here I have my list, which is a very simple list with 4 elements, and I'll just run my for loop against my list and print out each element one by one, like so. That is plain and simple, and we do it every day. But I wanted to understand exactly what goes under the hood, so I tried researching. So found out that what for loop is doing for us is actually an abstraction of a much more detailed work that Python does to make it simpler for us. So the first thing it does is actually it converts my list, which is an iterable in Python terminology, into an iterator. So you might be wondering, what is an iterable? So in plain and simple term, an iterable is something, an object, it's not something, it's an object that is able to give you or to be, that's able to produce each of its elements one after another in ordered or in unordered fashion. And when it comes to object-oriented programming terminology, it implements something called iter method. So if it if it implements double underscore iter method, like so, then that object we can call it as iterable. And then what's an iterator? An iterator is an object that implements next underscore next. So why am I talking about iterators and iterables before diving into the hood? It's because for you to be able to understand, you have to understand these two things first. My first assumption when I was first learning Python was because I was introduced to iterators as something that as objects that allows us to loop over iterables. I thought a for loop is an iterator or a while loop is an iterator, but that's wrong. Iterators, as I explained earlier, are objects with next method implemented in them. And how do they help us here? Well, they help us manage iteration of iterables. So here, for example, what for loop does for us is under the hood, it creates an iterator object out of my list. So let's say my list iter, and then I'll use iter function and I say my list. So this will return an iterator object. Oops, we made a mistake there. There's no S. There you go. So now I have an iterator object. Why do I need an iterator object? Because iterator object, as I said earlier, has next method, which will allow us to fetch the next method each time we call next. Right, let's go and call next now. So now that we have my list, we can go and say next my list iter 1. Let's try and call this one more time. 2. 2 again. 4. And what happens now when I run it again? If you notice, every time I call next, I'm getting the next element. What happens now? Stop and think. So what happens now is Python will raise something called an exception. That exception is called stop iteration exception, and then it won't perform any other operation from this point onwards. So coming back to the what for loop does for us whenever we perform such kind of script is that it handles the exception silently for us and quietly produce 1 up to 4 and breaks when that breaks out of a loop and produce this result when that exception is risen. So in a nutshell, that's what for loop does for us. Moving on. Now, how can we implement this thing now? If we don't want to use for loop, let's say, what is our option, right? Our option can be a while loop. So we can use while loop as well. So here we can say while true. We have our list here. Let me just bring it down here. So our aim is to iterate over our list. So we convert our list first. My iter list, let's say in this case, is iter. First of all, I just want to point out some other thing as well. Iter and then sequence is syntactic sugar to my list dot double underscore iter double underscore. These are basically the same thing. It's just Python's way of making it Pythonic, if you will. So you can use this, and the same goes for next as well. When we call next after this, let's just use this one for now. In Python, this is called dunder. So by doing this, we're calling we're initiating an iterator object, and now that we have an iterator object, we can call next from my iter list. So here we have a try catch, so that we can capture the exception. Except stop iteration, and then here we print you've we need to use double quotes. You have reached the end. Okay, and then here we print my iter list next. So now let's try and run this and see what happens. Yeah, so we must not forget to break, otherwise this will run forever, so I have to break it. There we go. So basically this is what for loop does without the message. It goes through your list items. It first takes your list, creates or initializes an iterator object from your list. It calls next every time to fetch the next item in the list, and then once you run out of your list, it raises stop iteration so that it stops looping, and then it breaks. So in a nutshell, a for loop is the same as this right here. So what else can we understand from this? We can also go a little bit deeper. Now we've gone one abstraction level down and understood or peek, if you will, under the hood, and we have seen how for loop does its magic when it's iterating over a list. The second idea that I want to share with you is below this abstraction, there's also another level of abstraction that we can look at, which is how the Python interpreter executes our code. In order to do that, you will have to import a library or a module called dis. Stands for disassembly. It's a native library, so you don't have to download it. Just import this, and just for the sake of demonstration, I'm using very simple list that has 3 items, and then I'm going to use for loop here to iterate over it, and then I will call my function with this method. So this.this function, and then it generates this bytecode. Okay, so these are basically, if you just save this file, for example, you'll find it and save it as, let's say, x.py. After you run this program, you will find another file called x.pyc, which is the compiled version of your Python file, and this is what you would find in that file, the bytecode version of it. This is platform independent, it runs anywhere. So let me just try to walk you through and create like some sort of like a mental model for you to understand what goes under the hood even further. So first thing it does is load const. This is an instruction that loads constant values such as 0, 1, 2, 3, none, string, whatever. So in this case, what we're doing is loading 1. All right. And you might ask, where is it loading it? So the Python interpreter is a stack-based virtual machine. So therefore, it's storing this in a stack. And I'll try to give you some sort of visual representation here. So load const loads 1 into the stack. I have a graphic that actually demonstrates what stack looks like. This is a stack. Whenever you see a stack, picture an empty barrel. Okay, so it's kind of last in, first out kind of method. So the last item you put is the first one to come out. So operations are called push and pop. So push is to insert. So in this picture, for example, we're pushing 1 into our stack, and then in this one we're pushing 2. So the stack has now 2 elements, 1 and 2. As you can see, the last item is the first one to come out when we're popping it. So push 3 again, and then pop, we're popping 3 out. Right. So load const basically is like pushing 1 to the stack, 2 to the stack, 3 to the stack again, and then we call another instruction called build list. So when we say build list, the stack now has a list that contains 1, 2, 3. So first instruction is to load. The first bit is to load our constants, which are 1, 2, 3, and then we build the list. And what do we do next? Then store fast. This command stores our list, the one that we just built. So now earlier, until this point, right, our stack had 3 elements. Now our stack has 1 element as a list. All right. Then store fast stores our list in memory. This is just a stack, a separate virtual machine stack. Now our list puts our store fast puts our list in memory and give it a reference called my list. So my list now knows where to find our list. So after this, our stack is empty. You see here, stack is empty, right? Now moving on. Load fast. Now load fast takes an argument, my list. So that means we're now loading our list back to the stack, and then get iter. Now we're adding the iter object. So basically we're converting our list into iter object, exactly what we've done earlier here. If you notice, if you remember, sorry. I think we've done it here too. Yeah. So this is basically what it does. When it calls get iter instruction, this is what happens. So get iter, and it doesn't take any kind of argument, and then for iter 228. So this is where the for loop starts, right? It starts to iterate over our list, and then 228 is where we load const none. I will explain this later when we reach this point, but for now, think of it this way. It will iterate the for loop. Once the loop ends or breaks out of the loop, it jumps to line 28. That's what it is. All right. So moving on, we are here for iter and then store fast item. So for iter, what it does is it calls the next function within it, and the next function, as we discussed earlier, when we first invoke the next function here, it gives us the first element, which is 1. So now 1 is stored in item, because in our case we're storing everything one by one in item variable temporarily. We print it out, and then item is empty again, and then we put the next one in item. So because that's what we're doing, we're now storing the first value we got out of that list in item variable and store it in memory. Whenever we say store fast, it's to store it in memory. That's stored, and now our list is empty again. Where are we? All right, so get iter, we get it, we're here, and now store is empty. Moving on. Now we're gonna load global print. So print is a global function, so we're loading it. So our stack now has one element, which is a global function called item, and then we load fast. Load fast. Now we're adding item. Item, we store fast it here. Store fast item, and it contains one. We know that. So now we added print. We added item. Our list has 2 items now, and then we call function. When we say call function in this stack, so far we only have one function, which is the print function, and we're calling it. When we call it, print displays 1, right? So then we see 1, like we see 1 here, we see 1. After that, it says pop top. Pop top, you might say, like, why does it pop top? Because after we call the function which shows 1, we have to call pop top, because print behind the scene returns none. After showing the value, it returns none. So that none is stored in our stack, and we want to get rid of it. So we get rid of none, our stack is back to empty again. So let's go back and see, try to visualize this. So we print function, we added load global print, load fast item, which is 1, call function, returns none, and then pop top makes our list empty, our stack empty again. So now we have reached this part, and then here it says jump absolute 14. That means go to line number 14, which is the 4. So this is where the iteration happens between line number 14, position number 14 and 26. In between, so however many items we have, they get iterated here. When that stop iteration exception is raised, the loop breaks, and then we reached here, load const 0. Load const 0 takes 0 argument and puts none in our stack here. Pop top, then loops back forever, loop ends. So here, let me go back and explain. So load const 0 needs to, because our function, if you notice, this loop function doesn't return anything, therefore doesn't return anything, it doesn't mean it doesn't return at all. It returns none actually behind the scenes. So we have to load that value, which is none, and then return that value, which is none. That's why whenever we run a function that doesn't return any value, behind the scene it returns none, just like how print returns none. We have to get rid of it, but here we're returning none. Otherwise the caller doesn't know whether the function has executed properly or not. So this is my deep dive for you. We started out with a very simple list, just to wrap up. Where was it? Yeah, this is a different one. Yeah, right here. We started out with this loop, with this list. We looped over it. We discussed about iterators and iterables, where I touched up where iterator needs to have dunder next method to be called an iterator, and an iterable needs to have a dunder iter method to be called an iterable. An iterable and dunder, an iterable needs to be converted into an iterator object in order to be iterated over, because that then only we can call the next function to get the next value out of this iterable object. That next value gets the next value, that next method gets the next value, updates the state of the iterator object. That way we know where we stand and how many values are left, and to be able to stop iteration, raise the stop iteration exception as well. I hope it's not too long-winded. I hope I made it clear, but if there's any questions or comments, feel free to leave them. Thank you.